Good evening and welcome to today's episode of Chemistry with Tutor John O. Now today, quickly, I'll be taking notes on how to write the molecular formula with radicals. Molecular formula with radicals. Although I told us we're going to be learning how to know oxidation number of elements, but please stay tuned to that to know something. When oxygen is reacting with a particular element, it gives sulfates, ATE. For example, sulfur reacting with 3 oxygen. Now from 3 oxygen and above, it ends with AT. For instance, now we have sulfur and oxygen. This gives us sulfate. But in the Iupac naming, you call it tri-oso. 3 oxygen involved, tri. Then the oso for oxygen. Then the sulfate is sulfur reacting with 3 oxygen. So be mindful of the ATE. Likewise here, this is 4, like I said, from 3 oxygen and above reacting is ATENC. So we have sulfate, this tetra-oso sulfate. Now this is 4 oxygen involved, sulfate, stay with sulfur. So here we have 3 oxygen, tri-oxo. There, carbon is involved, carbonate. ATENC because it is 3 oxygen involved. Here we have tri-oso nitrate, 3 oxygen, nitrates. Tri-oso nitrate. Nitrogen involved with 3 oxygen. Then for PO4, this is tetra-oso phosphate, tetra-oso phosphate. 4 oxygen involved, tetra-oso phosphate. So when it is 3 oxygen involved, ATEN6. Now when it is 2 oxygen involved, where you have SO2, then ITE, N6, ITE from 2 oxygen below is pronounced as ITE. For example, this is diisosulfites, 2 oxygen, diisosulfites. Likewise, we have nitrites, NO2, nitrites. This is sulfites, nitrites, ITE. So be mindful of when the oxygen, the amount of oxygen. Then if it is PO2, you could call it phosphite, and so on. So quickly, I want you to have that at the back of your mind. So today, we'll be using these radicals to write molecular formula. And then we move quickly to Iupac name of the periodic table. Now quickly, if sulfites or sulfates, tetraoso sulfates, will be reacting, and these are also called acidic radical. They are acidic. So acidic radical will be reacting, or say anions, they will be reacting with a cation. So all these are anions because they are negatively charged. So for tetraoso sulfate, say reacting with a metal. Now metals are positively charged elements. Metals are positively charged elements. Elements from group 1, 2, and 3. So they are donors of electron, so they are usually positively charged, and in most cases they react to form their unique bonding. Now, sulfates with, say, calcium. Now, if we have this, it should produce, this is also in group 2, plus 2. Now let me just give us a clear, say, calcium tetra also sulfate dash. So how do we write the correct molecular formula for this compound? Now, having understood the radicals we have, we can work with that. Calcium, identifying the symbol Ca, tetra also sulfate. Now, sulfate, I already know that it is SO4, 4 oxygen reacting with a sulfate from the previous knowledge. That's sulfate, ending with V. So, and tetra already give me the insight that it is 4 oxygen. So, and then this radical is usually carrying a 2 minus, that's the oxidation number is -2. So, you write it on top. Calcium is from group 2. So, the oxidation number is +2. So, we cross multiply. When we cross multiply, this will carry 2, the signs are not needed. So we have 2, 2. In this case, the 2 cancel out. So when the 2 cancels out, it's just CaSO4. This is calcium sulfate. Now, how do we quickly know, or how do we know the numbers that is here to now pronounce the actual Iupac name, the full correct Iupac name? Let's quickly look at the calculation. Now, we are looking for sulfate what? So the center element here is sulfur. So we calculate the oxidation number of elements in a compound. So we are calculating that of sulfur to find out the actual correct Iupac naming of this compound. So calcium is in group 2, say +2 plus calcium and sulfur is the central element represented as S. Then we have plus oxygen. Oxygen is also in group 6, so the oxidation number is -2. Remember the octet state subtraction. -2 for oxygen, then we have 4 oxygen times 4, all equals 0. Then we solve the mathematics, bring it closer. 2 plus x minus 2 times 4, that gives us -8. This times this, minus, plus times minus, all equals to 0. So here if we have x, we collect the like times to solve for x. X equals to 8. 8 was initially a negative sign, so the sign changes. 2 here was positive, then -2 it becomes. So we have 6. X equals 6. So the oxidation number of sulfur is 6 plus 6. So we have Roman figure. That is why when you pronounce the Iupac name, we have calcium tetraosulfate 6 by the virtue of this calculation. Now let's look at one more quickly. Magnesium triisocarbonate what? Now first and foremost, identify the symbol of the element. Magnesium, Mg. Triisocarbonate, that gives me the idea. NAT, ATE, that is 3 oxygen involved, triazo, then carbon. So CO3. The radical for this is -2. Magnesium is a metal of group 2. The oxidation number now is +2. So when we have it cross multiply like earlier, the signs does not matter, they equate. So 2 cancels out. Then you have magnesium carbonate, MgCO3. But now the correct Iupac naming is now what? That's what we calculate for from your molecular formula. Now calculating carbonate is carbon is the center element here. So we find out magnesium in group 2, so oxidation number is +2. +2 plus carbon, X represented as S, plus oxygen is -2. We have 3 times 3 oxygen, all equate 0. So we break it down, we have 2 plus X minus 2 times 3, 6 equals 0. So in this case, we collect like times. X equals to 6 being negative here changes to a positive. 2 here there is an invisible positive here, -2. So X equals 4. So X, the central carbon here, the oxidation number of carbon in this compound is +4. So we have magnesium triisocarbonate 4. This is the molecular formula. Thank you for